welcomes you to State Live Lecture of Geometry. I, Sujata Verma from Kolaba Secondary School, welcomes to you in today's lecture. Students, yesterday we started the revision of chapter number 5, that is Coordinate Geometry. This chapter is totally based on formulas. Okay, this chapter contains only 3 topics: section formula, distance formula, and centroid formula. And the fourth topic, that is the slope of the line, is omitted from your syllabus. In yesterday class, we discussed the first topic, that is the distance formula. Okay, and today we are going to discuss the next topic, that is the section formula. Before starting today's topic, let's revise some concept or properties of the parallel line. So see, first we see the properties of the parallel line. Properties of the intercept made by 3 parallel lines on a transversal. So what is meant by parallel line and what is meant by transversal? When 2 lines having same direction, moving on in the same direction, then we say that these lines are parallel to each other. And third line cuts both the parallel lines, then we say that it is a transversal of the given parallel line. Okay, so in this figure, see, in this figure, there are 3 parallel lines, L, M, and N. These 3 lines are parallel to each other. Okay, and this line A is the transversal, and line B is also the transversal. Okay, so to divide the line segment in the given ratio, first we said that this line segment divides into ratio P1, P2, P3, and so on. So this one is the intersection. So we say that this show that this point, say in the second figure, this line segment PQ and line R divides this line internally in some ratio. We say that the ratio 1:2, 2:3, like that. So this point R divides the line segment PQ internally in the ratio M:N. So we say that when 2 lines are parallel to each other and the given line is transversal, it cuts the line in the given points. So here A line cuts the line L, M, N in A, B, and C. Line B cuts D, E, F respectively. Okay. See, in this section formula, here we have the line segment PR. Line segment PR. And Q is the point which lies between the line segment PR. So Q point lies between P and R. So we say that PQ is to QR. See in the figure, the distance between PQ is equal to 9 and distance between QR is equal to 12. So we write PQ is to QR is equal to 9:12. Okay. Then we take PQ by QR is equal to 9/12. These two numbers are divisible by 3. So we write 3 3s are 9, 3 4s are 12. So we get the given ratio 3:4. So we say that this point Q divides line segment PR in the ratio 3:4. Or we can also use the word this point Q divides the line segment PR internally in the ratio 3:4. Okay, so in this way we find the point divides the line segment internally or externally. See in the again we discuss the internal division of line segment. See in the if P is any point on the line segment AB. See, we have the line segment AB and P is the point which lies between the point A and B. Then P divides segment AB internally. Means P divides this line segment internally. So P divides segment AB internally in the ratio AP by BP. Okay, here we use the word internally. So we say that this point P divides the line segment AB in the ratio AP by BP. Okay, so here we write AP by BP. Okay, and this ratio, the ratio in which P divides line segment, is always taken as positive. Next, section formula for internal division. So this one is the important formula. So first we find the formula. The coordinates of point which divides the line segment AB, joining the points A having coordinates x1, y1 and B having coordinate x2, y2. So here we have line segment AB. We have line segment AB. So A having coordinate x1, y1, B having coordinate x2, y2. And this line segment divides internally in the ratio m:n. So which point divides this line segment? Point P divides this line segment internally in the ratio m:n. So we write internal section formula. That is, first we write the Yes, we write x coordinate. Yes, x for x coordinate, we write m into x2 plus n into x1. Wait, please wait. Yes. Yes, we write. For x coordinate, we write m into x2. Yes, m into x2 plus n into x1. N into x1 divided by m plus n. Okay, so here we write x coordinate m into x2 plus n into x1 divided by m plus n. For y coordinate, we write m into y2 plus n into y1 divided by m plus 1. So this is called the section formula for internal division. This formula is very important. mx2 plus nx1 divided by m plus n, and for y coordinate my2 plus ny1 plus divided by m plus n. Okay, so here we derive our formula, section formula for internal division. Now, what are the applications of section formula? So the application, first application is the midpoint formula. So this one is the first application of section formula. Suppose this point P, which divides the line segment internally, this point P is the midpoint of the line segment. So this one is the first application. So we say that we have point P having coordinate x comma y is the midpoint of the segment AB. Okay, A having coordinate x1, y1, B coordinates is x2, y2. Then we say that here it divides m is to n ratio. But the condition is that this point is midpoint. So we write m is equal to n. Okay, midpoint means this distance is and this distance are equal. So we write here by using section formula m into x2 plus n into x1 divided by m plus n. So here we use, in place of n, we use m. Okay, so mx2 plus n mx1 divided by m plus n. So we get m common here, x2 plus x1 divided by 2m. So this m get cancelled. We get x2 plus x1 divided by 2, or we can write x is equal to x1 plus x2 divided by 2. So here we get the x coordinate of point P, x1 plus x2 divided by 2. Similarly, we can also find y is equal to my2 plus my1. Same, m is common, m plus m 2m. Then get cancelled. We get y2 plus y1 divided by 2. So here we get y coordinate is equal to y1 plus y2 divided by 2. Okay. So in this way, we find the formula for so here we find midpoint formula. So if any point is the midpoint of the line segment and divides in the ratio in equal parts. So that means we write x coordinate x1 plus x2 divided by 2 and y coordinate y1 plus y2 divided by 2. So let's do one example based on this formula. Here we have a line segment A and B. Okay. Find the coordinates of point P which divides segment AB internally in the ratio m is to n in the following cases. Okay. So here we have line segment having coordinates 2, -5, -3, -7. And this line and here divides the line segment in the ratio 3:5. So first we write we write one by one. Let P is the point having coordinate x, 1. By using section formula for internal division, m into x2, n into x1 divided by m plus n. So here we have the value of mn, x1, x2. So here we put m is equal to 3 and n is equal to 5. x1 is equal to 2. x2 is equal to -3, y1 is equal to -5, and y2 is equal to -7. So here we get all the values. M is equal to 3, n is equal to 5, x1 is equal to 2, x2 is equal to -3, y1 is equal to -5, and y2 is equal to -7. Okay, so by using these values, we find the x coordinate and y coordinate of this point P. So substitute here all these values. Put 3 into -3 plus 5 into 2, that is -9 plus 10 divided by 8. So we get x is equal to 1 by 8. Similarly, we find the value of y. Y is equal to -23 by 4. So finally, we write the answer. The coordinates of point P are 1 by 8 and -23 by 4. Okay. So here first we identify the values of m, n, x1, x2, y1, y2, and by using the internal section formula, we find the coordinates of the point which divides the line segment internally. Okay. Now next question. In what ratio does the y-axis divide the segment joining A 3,5, B -6,7? Find the coordinates of the point of division. See in the figure, we have 2 points A and B. When we join these points, we get a line segment. But the question is that in what ratio does this y-axis divide the line segment? Okay, so we have to find the coordinate here. We have to find the coordinates of the point P which divides the line segment on y-axis. Okay, so one by one, first we write let point P x, y divides the line segment AB internally in the ratio m:n. So here we write m:n. Okay, since this point P lies on y-axis, since this point Y lies on y-axis, that means its x coordinate is 0. So we get P is equal to 0, y. Okay, it's clear. If this line segment touches x-axis, then its y coordinate is 0. But this line segment touches y-axis, that means its x coordinate is 0. Okay, then we use the section formula for internal division. X is equal to mx2 plus nx1 divided by m by n. So here we find the coordinates of point of division. So first we find Here x value is 0, m as it is, n as it is. Okay. Then first we find the ratio m by n, that is equal to 1 by 2. So we write, this means that the y-axis divides the line segment in the ratio 1:2. And this ratio is 1 and this ratio is 2. Okay. So in this way we find the ratios. We also find the ratios. Okay. At which ratio this line segment divides. Okay. Next question. Find the coordinates of the midpoint P of segment AB if A equal to 3.5, 9.5 and B is equal to minus 1.5, 0.5. Okay. So here we have 2 points A and B. We have to find the midpoint, that is P is the midpoint of the line segment AB. So first we consider let A coordinate, let A coordinate is x1, y1. From this we get the value of x1. x1 is equal to 3.5 and y1 is equal to 9.5. Okay. From this we find x2. x2 is equal to x2 is equal to 1.5 minus 1.5 and y2 is equal to 0.5. Okay. Then we use the midpoint formula. Midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 6. It's very simple. Substitute the values. 3.5 plus minus 1.5 divided by 2. Okay. So this one is minus, plus, minus, minus. So we get 2 by 2. Get cancel 1. Okay. Similarly, 9.5 plus 0.5, that is equal to 10. So 10 by 2 equal to 5. So here we get coordinates of the point P, which is the midpoint of the line segment AB. Simple question. Okay. Now next question. In what ratio does the point 1, 3 divides the line segment joining the points 3, 6 and minus 5, 6 internally? So here we have 2 points. Okay. 2 points. This one is point A having coordinate 3, 6 and point B having coordinate minus 5, 6. And again another point divides the line segment, but we have the coordinates of this point and we find the ratio, at which ratio this point divides the line segment. So here we have to find the value of m is to n. Okay. So first we write x1, x2, y1, y2 value, and then we write let P is equal to 1, 3 equivalent to x, what divides the line segment AB in the ratio m is to n. Okay. Then we apply the section formula for internal deviation. So here you can consider x coordinate formula or y coordinate formula. Any one of this you can use. So here we use x is equal to m into x2 plus n into x1 divided by m plus n. So here we have x is equal to 1, x2 is equal to minus 5, x1 is equal to 3. Substitute all the values. Take this m by n on left hand side. So m plus n into 1 is equal to m plus n. Minus 5 into m is minus 5m. And this one is 3n. Okay. Then take m on left side, n on right side. So we get m plus 5m is equal to 6m. 3m minus n is equal to 2n. So here we find the ratio, that is m is to n. So m is to n is equal to 2 by 6. So 2 ones are 2, 2 threes are 6. So here we get m is to n is equal to 1 is to 3. So finally we write the point P divides the line segment AB internally in the ratio 1 is to 3. And in final answer, we are not using the line segment AB because in question points are not given. So here we write the point P divides the line segment internally in the ratio 1 is to 3. Okay. Now the next part, or we can say next applications of section formula is the centroid formula. Okay, so this one is the second application of section formula. First application is the midpoint formula, and the formula for finding the coordinates of midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. Here we consider the second one application, that is the centroid formula. So here we derive the median of the triangles are congruent. Here we know that what is meant by median. Median of the triangles are congruent. So here we consider D. D is see in the figure, D. D is the midpoint of BC. Okay. If D is the midpoint of BC, then we write A having coordinate x1, y1, B having coordinate x2, y2, C having coordinate x3, y3. So by using midpoint formula, we write x2 plus x3 by 2, y2 plus y3 by 2. Okay, that one is the midpoint formula. Here we say that this G is the centroid. If we use the word centroid, that means this G divides the line segment AD in the ratio 2:3. Okay, and here we have coordinate x2 plus x3 by 2 and y2 plus y3 by 2. So this point G divides AD internally in the ratio 2:1. So here we use the section formula 2 into x coordinate plus 1 into x1. Okay, and 2 plus 1. Similarly, we write y coordinate 2 into, here we use y coordinate plus 1 into y1. Okay, solve this. Finally, 2 get cancelled. 2 get cancelled. So we get x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3. So this, by using this formula, we find the centroid coordinates of the centroid. Okay, so this one is our final coordinates of centroid G, x1 plus x2 plus x3 divided by 3, y1 plus y2 plus y3 divided by 3. So here up to now, we derived 4 formulas. First one is distance formula. Second one is the section formula, midpoint formula, and the fourth one is the centroid formula. Okay, so by using this centroid formula, we find the coordinates of the point G. We have P. Yes, P coordinates is given. Yes, Q coordinates is given, R coordinates is given. So you have to find the coordinates of G. So first we write let P is equal to x1, y1, that is equal to 2, 7. So from this we write x1 is equal to 2, y1 is equal to 7. From coordinate Q, we get x2, y2. From coordinate R, we get x3, y3. Okay, simple. And then we write let G be the centroid of the triangle having coordinate x, y. So by using centroid formula, x is equal to x1 plus x2 plus x3 divided by 3, y is equal to y1 plus y2 plus y3 divided by 3. Then substitute all the values. X1 is 2, x2 is minus 5, x3 is minus 6. So minus 11 plus 2, that is minus 9 by 3. Cancel it, we get x is equal to minus 3. Okay. Similarly, we find y is equal to 7 plus 8 plus 1 divided by 3, that is 16 by 3. So take it as coordinates of the centroid is GR minus 3, 16. Okay. So here we find the coordinates of the centroid. Now let's do practice set 5.2. From your syllabus, practice set 5.3 is totally omitted. So this one is our last practice set 5.2. So let's do one by one. Find the coordinates of the point P if P divides line segment joining the points A, B in the ratio 2:3. So see in the question, here we have two coordinates, 2 points A and B. Okay, and we have the ratio. So we write let we have A is equal to minus 1, 7 and B is equal to 4, minus 3. Let the coordinates of point P divides P with the x, y. Suppose the coordinates of point A is x1, y1 and B is x2, y2. From this we get x1 is equal to -1, x2 is equal to 4, y1 is equal to 7 and y2 is equal to -3. Okay, and we say that this point P divides AB in the ratio 2:3. It means M is equal to 2 and N is equal to 3. Then we use section formula. X is equal to mx2 plus x nx1 divided by m plus n, and y is equal to my2 plus ny1 divided by m plus n. So one by one we find, first we find the x coordinate and then we find the y coordinate. Substitute all this value here. 2 into 4 plus 3 into -1, 2 plus 3. Okay, so we get 5 by 5. Get cancel, we get 1. Okay, so x is equal to 1. Then substituting after calculation, we get 3. So y is equal to 3. So finally we write the coordinates of point P are 1, 3. Okay, so in this way we find the coordinates of the point P. Second question, same way we write in each of the following example, find the coordinates of the point A which divides the segment PQ in the ratio A is to B. So students, here I take only one question from your practice set. So I hope you all you solve remaining questions from your practice sets. So see, first question is P -3, 7, Q 1 - 4, and the ratio is 2:1. So simply what you have to do, first from the given point you find the value of x1, y1, x2, y2. Okay, and from the given ratio you will get the values of m and n, and using section formula substitute all this value and you get x and y coordinate. Okay, so same like in previous question, same process is here. First find x1, y1, x2, y2, and from ratio we get m is equal to 2, n is equal to 1. Then write the section formula and you will get x value and y value. Okay, again we take another example. Here we have 2 points P and Q, and the ratio is 1:2. So x1 is 2, x2 is -4, y1 is 6 and y2 is 1, and m is 1 and n is 2. So substitute in this, so we get x is equal to 0. Yes, x is equal to 0 and y is equal to 13 by 3. Okay, now next question, question number 3. Find the ratio in which point T, that is coordinate -1, 6, divides the line segment joining the points P -3, 10 and Q 6, 8. So see in this figure, what we have to find? We have to find the ratio. We have 2 points. When we join these 2 points, we get line segment. So we have line segment PQ, and T is the point which dividing the line segment internally. So here we have to find the ratio, at which ratio this point T divides the line segment PQ. Okay, so first we write P coordinate -3, 10 and Q coordinate 6, -8, and point T -1, 6 divide PQ in the certain ratio. Okay, now suppose the coordinates of the points P are x1, y1 and Q are x2, y2. That means from point P, yes, from point P we get x1, y1, and from point Q we get x2, y2. Okay, and we consider T. Let the coordinates of point T is x, y. That is equal to, from this we get x is equal to -6 and y is equal to 6. Okay, so here we use 2 methods. You have to use any one of these. This one is method 1 and method 2. Okay, so first we write directly x value, that is x is equal to m x2 plus n x1 divided by m plus n. Substitute all this value in this formula. So you find the ratio m is to n. Or you can also use the y coordinate formula. Okay, y coordinate formula means y is equal to my2 plus ny1 divided by m plus n. Okay, substitute all this value, you get the ratio m is to n is equal to 2:7. So you can use any one, either use this one or either use this one, but you get your final answer. Question number 4. Point P is the center of the circle and AB is the diameter. Okay, so here P is the center of the circle and AB is the diameter. Find the coordinates of point P if coordinate of point A and P are 2, -3, -2, 0 respectively. See, in this question, okay, we have the coordinates A coordinate and P coordinate. Okay, and we find what we have to find. We have to find the coordinates of point B. Okay, so first A coordinate and P coordinate given. So let me consider the coordinates of point B are x2, y2. P is the midpoint. See, here use word midpoint. That means this and this distance are equal. Means m equal to n. So if m equal to n, that means we are using the midpoint formula here. So we use midpoint formula x1 plus x2 divided by 2, y is equal to y1 plus y2 divided by 2. Okay, so here we have value of x value. We find x2 from this formula. We have y is equal to 0 and y1 is equal to -3, and we find y2. So x2 is equal to -6 and y2 is equal to 3. So finally, B coordinate -6, 3. Okay, so we consider here x2, y2. So value of x2 is -6 and value of y2 is 3. Okay, so in this way we find the coordinates of point P. Sometimes they may ask like that, A and B, okay, coordinates are given. You find the coordinates of the center of the circle. So simply, this one is x1, x2, x1 plus x2 divided by 2, y1 plus y2 divided by 2. But in this question, they give the coordinates of the center and one coordinates of the line segment. Okay, so you find the another one. Question number 5. Find the ratio in which point P, k, 7 divides the segment joining A and B. Also find k. First you find the ratio, and then after finding the ratio, find the value of k. Okay, so here we have A and B and P. First we write our given values. A having coordinate 8, 9, B having coordinate 1, 2, and P k, 7. So here we use the what this line point P divides the line segment AB in the ratio m is to n. Okay, then first we find the ratio. We are using the formula, section formula here. So y is equal to my2 plus ny1 m by n. So see, in this question we have two methods for finding the ratio. But why we are using this y coordinate formula? Because here the x coordinate is k. Okay, and the y value is 7. If we take x is equal to m x2 plus n x1 divided by m plus n. So by using this formula, we are not getting the ratio m is to n. The reason is that at the one time, we are not able to find the values of x and m plus n. Here, the value of x is k. So we use the another formula, that is y coordinate, because the y value is 7. Okay, y2 is 2, y1 is 9. And from this, we can easily determine the ratio. So we write m is to n is equal to 2:5. Okay, so Because of this reason, we are not taken the x coordinate for finding the ratio. Okay, so by taken y coordinate formula, we find the ratio m is to n is equal to 2 is to 5. Okay, so first part is finished. Then they ask find the value of k. Okay, so here we use point P divides AB in the ratio 2 is to 5. Then we again use the section formula. At that time, we consider the x coordinate formula. X value is k, substitute m value is 2, m is 2, n is, yes, n is 8. Okay, sorry, n is 5. And x1 and x2 value, x2 is 1 and x1 is 8. Okay, substitute here 2 plus 40 divided by 7. So 42 by 7. So in this way, we find, first we find the ratio and then we get the value of k. Question number 6. Find the coordinates of the midpoint of the segment joining the point. Simple question, very easy. Asking for 2 marks. You have 2 points. Find the midpoint, coordinates of the midpoint. So simply, and draw a line. Here is the point A. Here is the point B. You have to write down the coordinates. 22, 20. Here we write 0, 16. Okay. So this one is the x1, y1, x2, y2. Then by using the midpoint formula, x1 plus x2 divided by 2, y1 plus y2 divided by. Substitute all this value. So finally you get x is equal to 11 and y is equal to 18. So the coordinates of the midpoint are, yes, 11, 18. Next question, 7th question. Find the centroid of a triangle. Oh, simple question again. Find the centroid of a triangle whose vertices are given. So here we use the second application, that is the centroid formula. So you remember the formula, that is x is equal to x1 plus x2 plus x3 divided by 3. Y is equal to y1 plus y2 plus y3 divided by 3. Okay, so from the given points, we find x1, y1, x1, y1, x2, y2, x3, y3. So first we write one by one. A minus 7, 6, B 2, minus 2, C 8, 5. So A has coordinate x1, y1, B has coordinate x2, y2, and C has coordinate x3, y3. So from this, x1 is minus 7, x2 is 2, x3 is 8, y1 is 6, y2 is minus 2, and y3 is equal to 5. Let's the coordinates of centroid GB x, y. So by using centroid formula, x is equal to x1 plus x2 plus x3 divided by 3. So x is equal to 1 and y is equal to y1 plus y2 plus y3 divided by 3. Substitute the values, we get y is equal to 3. So the coordinates of centroid are 1, 3. Now next question, in triangle ABC, G means centroid and its coordinate is minus 5, 7. If A minus 14, minus 19 and B is 3, 5, then find the coordinates of C. Okay, so here first we draw the triangle. A point, B point and C point. So you have to write down the coordinates. A is given minus 14, minus 19. B is given 3, 5. So we assume this one is x1, y1, x2, y2, and this one is x3, y2. Then we draw the centroid. So this one is G. Having coordinate, yes, G coordinate is given. Wait. Yes, G coordinate is minus 4, minus 7. Okay, so yes, G given, A given, B given. We find C. Suppose the coordinate of G are x, y and coordinate of A is x1, y1, B is x2, y2 and the coordinate of C, B, x3, y3. This one is this assume, and this one A and B and G are given. So from GAB, we find x1, y1, x1, y1, x2, y2, and from G coordinate, we get the value of x and y. Then use the centroid formula. X is equal to x1 plus x2 plus x3 divided by 3, and y is equal to y1 plus y2 plus y3 divided by 3. Substitute all this value. We have to find the value of x3. Substitute x value, x1, x2 value, we get x3. Here, substitute. Yes, substitute y, x, all values. So x3 is equal to -1 and y3 is equal to -7. Okay. Next question. A coordinate given, B given, C given are the vertices of triangle. Centroid given, find H and K. Similarly, like previous question, we solved this one. First, you have to find x1, y1, x2, y2, x3, y3. Then use the formula, centroid formula, substitute here, we get H and K values. Okay. So, see, this one is important question. Find the coordinate of the point of trisection of the seg AB with A and B. Okay, trisection. Tri means 3. So here P is the point which is point of the trisection. Okay, so P and Q, we take 2 points. First, we draw the line segment AB. We write the coordinates A and B. Okay, then we write P and Q are the trisection of the AB. Trisection means we have to take 2 points. Tetrasection means you have to take quadra, or tetra means you have to take 3 points. Okay, less than 1. So here we write AP is equal to PQ is equal to QB. These 3 are equal, are of equal length. So first we find AP by PB. So AP by PB is equal to PB. We write PQ plus QB. And since these points are collinear, so we write PQ plus QB. Okay, so substitute here, replace it. So we get AP by PB is equal to 1:2. It's very important. We get AP by PB is equal to 1:2. So from this ratio, we say that this point P divides AB internally in the ratio 1:2. Then it's easy. Apply section formula, then you can easily find P value. Okay, the coordinates of P. So use the section formula. By using section formula, you find x1, y1. Clear? Simple. But what is important in this question? In this question, the word point of trisection is important. So this type of question may be asked for 4 marks. Okay, so remember this. First, we take 2 points on our line segment. You have to draw the rough diagram, write 1 by 1 coordinates, and take 2 points on the line segment. Then say that these points are the trisection. That means this divides the AB in 3 equal parts. Trisection means these points divide the line segment into 3 equal parts. Okay. Then here we get the points, coordinates of point P. But we have to find the coordinates of Q. So again, Q is the midpoint of the, we use second method. Q is the midpoint of the PB. So by midpoint formula, you find the coordinates of Q. Or you can also apply same formula here. Here the ratio is 2 and here is the 1. See, this ratio is 1:2. Sorry. This ratio is 1 and this ratio is 2. Okay, so if we say that if this ratio is 2, so this remaining ratio is 1. So by when we using section formula, we say that 2:1 for finding the coordinates of Q. Or you can also find the coordinates of Q by using midpoint formula. P and B. So take it as x1, y1, take it as x2, y2. By using midpoint formula, you can easily find the coordinates of Q. Okay, student. So in this way, you solve this type of question. See in question number 11, just I give some hints. It's the word 4 equal parts. 4 equal parts means we take 3 points. Okay. In previous question, try section. Here is the 4 equal parts. So here we consider point P, Q, R. Okay. So we have to find the coordinates of P, Q, R. So one by one, first we say that AP equal to PQ equal to QR equal to PB. Clear? Then this Q is the midpoint of AP. So by midpoint formula, easily you get the coordinates of Q. Simple. Here we say that point P is the midpoint of AQ. So again, use midpoint formula, you get coordinates of P. R is the midpoint of QB. Again, you can get the coordinates of R. So in this question, you apply 3 times the midpoint formula. Clear? And last question, that is A coordinates given, B given, find the points, 5 congruent parts. So here the word 5. So we consider P, Q, R, and S. Okay. So see, if the given parts are in odd number form or even number form. If they are given in even number form, so use midpoint formula directly. And if the question they ask in odd form, like that 5 is the odd number, then use section formula. It's just like a hint. Okay. So see, here the word 5 congruent parts. So we apply section formula. Just divide into 5 equal parts. Okay. So we get this ratio is 1 and this ratio is 4. Okay. 4 plus 1 is equal to 5. So we write AP by BP is equal to 4:1:4. If we get the ratio, then easily by using section formula, we find the coordinates of P, Q, R, and S. So in this way, we solve our practice set 5.2 here. In next lecture, we will solve our problem set 5. Okay, students. So if you have any doubts, so you can ask.
Students, any doubts? Raise your hands.
Yes, Aditya. No one is raising.
No one. Okay, we can wind up here.
Ma'am. Okay, ma'am.
Okay, thank you, ma'am.
Thank you, ma'am.